Hello everybody from home. This is the video you need to watch before Monday's lesson. It's the second day on 9.4, completing the square. Back in chapter 8, we learned that there's 3 different ways to write quadratic functions: standard form, vertex form, and intercept form. All 3 of these formats have an a variable at the front. We learned last chapter that a can affect whether the parabola is opening up or opening down. If a is positive, a positive number, the parabola will be opening up. If the parabola is opening up, it will also have a minimum value. That's the lowest point on the parabola. If a is negative, the parabola will open down. A parabola opening down will have a maximum point, or the highest point on the parabola. Now notice that the lowest point on the parabola, also called the minimum, is in the same spot as the vertex. This point here is both the minimum and the vertex of the parabola. If the parabola is opening down, it will have a maximum, a high point. Also, this point here is the same as the vertex, cuts the parabola in half. Now if we go back to these formats, to find the vertex when you're in standard form, we need that formula, which is negative b over 2a. That finds the x-coordinate, and to find the y-coordinate, you got to plug in your answer. So today you're going to be asked to find the minimum and maximum points, which is another way of asking you to find the vertex. Since the minimum and the vertex are the same point in this scenario, and the maximum and the vertex are the same point in this scenario. All right, so here's some example problems. Determine whether the function has a minimum or a maximum, then find the value. So this particular function is in standard form, and the a variable is the one I'm most interested in. The a variable is the invisible number in front of the x squared. In this case, that's a 1. 1 is positive, which means the parabola is going to be opening up. If a is positive, the parabola opens up. Since the parabola is opening up, that means it will have a very low point. In other words, it will have a min. So the answer to question 1 is this parabola, this particular quadratic function, is going to have a minimum. Next, they ask me to find the value of that point. What we need to do to find this minimum value is find the vertex. Now remember, in standard form, to find the vertex, you use this formula, negative b over 2a, and to find the y-coordinate, plug in the answer. Negative b would be negative 4 over 2 times my a, which is 1. This right here should give me my x-coordinate. Negative 4 divided by 2 is negative 2. Then I have to plug in negative 2 in for both of these x's to find the y-coordinate. So negative 2 squared is positive 4, plus 4 times negative 2 would be negative 8. So I've got a positive 4 minus 8, which is negative 4, minus 1, which would be negative 5. Okay, so this minimum point is located at negative 2, negative 5. Okay, and it's the y-coordinate in particular we're interested in. The x-coordinate moves the vertex left and right, but the y-coordinate tells exactly how low that minimum point is. That parabola drops to a lowest point of -5. Okay. So our first answer was that this quadratic function will have a minimum, and the second answer is that the minimum will be at -5. Okay, here's another example. Will this parabola have a minimum or maximum point? Remember, if a is positive, the parabola will be opening up. If a is negative, the parabola will be opening down. In this case, it looks like my a is a -1. That means the parabola will be opening down and have a high max point. So the first answer is this quadratic function will have a max. Now I need to find that maximum value. So again, I need to find the vertex here. Since this quadratic function is in standard form, again, I can just use this -b over 2a to find the vertex. My b is a 2. When I plug it into the formula, it becomes a -2 over 2 times a is a -1. So this right here will give me my x-coordinate of my vertex. -2 divided by -2 is a +1. Okay, now I need to plug in 1 in for each of these x's to find the y-coordinate. -1 squared plus 2 times 1 plus 7. Okay, that'd be 7 plus 2 minus 1, which would be 8. So, again, the x-coordinate isn't really the answer that they're looking for. That just tells you where the vertex is, left to right. The y-coordinate says that the maximum point on the parabola is all the way up at +8. So my first answer is that there will be a maximum, and my second answer is that the maximum is at 8. All right, last example here. Here I have a quadratic function that's already graphed with 4 different choices. Which of the functions could be represented by the graph? Explain. So let's start with option number 1. F of x equals -1/2 times x plus 4 squared plus 8. This quadratic function happens to be in vertex form. Notice the a is a -1/2, which means the parabola should be opening down. It is. Okay, the 4 and the 8 are going to give me my vertex. Remember, when you are in vertex form, to find the vertex, all you have to do is take h and k. When you pull the h out, it becomes a -4 and k is 8. So my vertex in this particular scenario is -4, +8. Now if I go to plot that point on the coordinate plane, -4, +8, the vertex should be located here, but that doesn't match what we see in the picture. So I would write f of x does not represent the graph because vertex -4, 8 is in quadrant 2. Okay, whereas clearly seen on the picture, the vertex is located in quadrant 1. Let's look at the second choice here, g of x. G of x equals negative times x minus 5 squared plus 9. This particular equation is also in vertex form. The a is in a -1. Remember, if A is negative, the parabola opens down. So that's good, that matches the graph. My vertex, HK, in this case is +5, 9. Now if we go over 5 up 9, that seems like it also matches this picture. So I would say that g of x could represent the graph. And the reasoning would be because A is negative, which means the parabola should be opening down, and vertex is in quadrant 1, because the vertex in this case is 5, 9. Okay, so g of x could be a plausible function to represent this graph. Okay, let's look at option 3, m of x. M of x, this happens to be an intercept form. X minus p, x minus q. Remember, p and q should be the two x-intercepts, or zeros, or where the parabola is rooted into the soil. When we pull the p out, it becomes a +3, and when we pull the q out, it becomes a +12. So, does it make sense that the parabola is rooted into the soil at 3 and 12? Well, here are the two roots. Does this point look like it could be 3 over? Yes. And here's the second root. This point also looks like it could be 12 over. So P and Q make sense. However, the A here up front, the A is an invisible 1, a +1. If A is positive, the parabola should be opening up. This parabola is opening down. So I would write m of x does not represent the graph. And the reason would be because A is positive. Okay, option number 4, P of x. P of x is also written in intercept form, the last choice here. Notice that the A, the number up front, is negative, which means the parabola should open down, which it does. The P and Q are the two roots or intercepts. When you pull this out, it's a +2, and when you pull the Q out, it's a +8. Could the roots be at +2 and at +8? Yeah, this looks like it could be at 2 and 8. So I would write P of x could represent the graph because A is negative and roots are at +2 and +8, which seem to match the photo.